All right, your warm-up for today, just going back to some work on exponents because that's what we're going to be working with in Module 2, which is where we're going back to. Number 1, to evaluate that, we're using order of operations. Order of operations would say parentheses first, but we don't have any. The second step would be exponents, so we're going to take care of those. 3 squared, hopefully you remembered to put that as a 9 and not a 6 because it's 3 times 3. 2 to the 4th turns into 16, and 9 plus 16 is 25. Number 2, again, order of operations, there are no parentheses here, so we're going to start with the exponents. 5 squared is 25, 3 cubed is 27, 2 to the 4th we already had on number 1, that's 16. 25 minus 27 is negative 2. Add 16 to that, and I get an answer of 14. So hopefully you evaluated these two correctly. There wasn't any homework to check since you had just taken that test, so today we're working on the review of exponents, and you should have some guided notes handed out to you. If not, pause until you all have a copy of the notes in front of you. So exponents, we're going to assume that you had this in pre-algebra last year. And again, sometimes that's right, sometimes that's not. If you have not had this exponent knowledge last year, then my recommendation would be to YouTube some exponent property videos if what we cover today and tomorrow don't help you. If you haven't covered it, but you learn it from today's video and the next 2 days, then that's great. But if you need some help, I know there'll be some great videos on YouTube or Algebra Nation if you need to. So the first thing is we need to be able to label exponents and an expression x to the n. X is the base, the number attached to the n, which is the exponent. And just one thing, the whole thing x to the n is called a power. Now, the first type of exponents we're going to look at are what we call negative exponents. Negative exponents do not make a number negative. What they do is they make the number smaller, like a decimal. So we're not allowed to have negative exponents in expressions that are simplified, so we have to get rid of them. And the way that we get rid of them is we move its position. So for example, if the monomial or the expression on top has a base with a negative exponent, then we would move it to the bottom to become positive. It's kind of like that fraction bar has a magical power here. When you cross it, that exponent becomes the opposite. If the expression has a base with a negative exponent at the bottom this time, well, then to make it a positive exponent, we're going to move it to the top. So one thing to help you remember it is when you cross the line, we change the sign. And again, the biggest thing is a negative exponent does not make a number negative. Now, if I look at the first example, you're going to tell me, well, that's not in a fraction. Well, I can make it a fraction. And we make any whole number a fraction by putting it over 1. Well, the next question is, where's the negative exponent? That's right here. The only thing this negative exponent is connected to is the 5. So that's the only thing we're going to move here. Now, when I move that 5 from top to the bottom, and I cross that line, it becomes 5 to the positive 3. This one here really doesn't help us any other than to state that it is a fraction. Now, what's left in my numerator? Well, I can't just have an empty spot there, so we have to put a placeholder. And we put a placeholder of 1. Well, this isn't my final answer because I can still simplify 5 cubed. Well, 5 cubed means 5 times 5 times 5, which is 1 over 125. And there's your final answer. So again, negative exponents make the number move, does not make it negative. If I move to the second example, again, the same thing. We don't have a fraction here, but we know that that means everything is on top. So anything that has a negative exponent is going to move to the bottom. Now, I have a 3 and an r. The question is the 3, the r, or both of them connected to that negative 5? Well, if they were both connected, I would have to have parentheses around the 3r to connect them to it. Since there's not parentheses, it literally means only that r has an exponent of negative 5, which means the 3 doesn't move. It stays where it is because it doesn't have a negative exponent. So 3 stays on top, and I move that r to the negative 5 across the line, and it becomes a positive r to the 5th. Now, I don't know what r to the 5th is because I don't know what r is, so this is my final answer. Variables we don't have to evaluate like we do numbers. Go ahead and try the third one on your own, and let's see how you do. Check with a neighbor when you think you have your answer, and then unpause this when the whole class is ready to double check. So this one did start out as a fraction, and what's on top has a negative exponent. So I know that in order to make it a positive s to the 3, I need to move it from top to the bottom. So then I look at what's already in the bottom, which is a t to the negative 5. Well, again, remember, negative exponents are not allowed. They're a no-no. So since the t to the negative 5 is on the bottom, to make that exponent positive, we have to cross the line, which is going to move it to the top. And it becomes t to the 5th. There's nothing I can do with the t and an s, so this is my final answer. Our next rule deals with anything to the blank power equals 1. This is a rule that you're going to simply have to memorize. There is a reason behind this, but it's about an entire page long proof of the reason behind this. You can Google it if you're very interested. So this is something you just need to memorize. Anything to the 0 power equals 1. And some of you already did know this. I remember talking about at the beginning of the year. If you did not know this, again, here's your refresher. So the first one I have is negative 6 to the 0. Well, negative 6 is the only thing there. It's connected to a 0, so the answer is simply 1. Now on the second one, we have two things here. Both of them are not connected to the 0, so only the term connected to the 0 power is going to equal 1. So x to the 0 becomes 1, but that 3 is going to stay a 3, so 1/3. Go ahead and try the last one. Check with the neighbor to see if you agree. If you don't agree, discuss it, and then unpause this when you're all ready to check your answer. So here we go. The first thing hopefully you noticed is that the entire top, because it's in parentheses, is connected to that 0. So that's going to turn into a 1. The denominator, the f and the g, are not connected to a 0, so they're simply going to stay fg. So the answer is 1 over fg. Now we're going to talk about multiplication properties. We have two properties here. The first is when we multiply monomials with the same base. When we do that, for example, if I have x squared times x cubed, well, the bases are the same, they're both in x. Now, if I have an x squared, that means I have how many x's? Well, x squared means I have 2. If I have an x cubed, that means I have how many x's? I hopefully said that, 3. Well, now let's count up how many we have total. And we've got 1, 2, 3, 4, 5. So I know that x squared times x cubed says that I have x to the 5th. Well, what's another way that we could do that without having to do this in between step? So how could I get from x squared times x cubed straight to x to the 5th? And hopefully you figured that out, that we're going to add the exponents. So when we multiply monomials with the same base, we're going to add the exponents. If they don't have the same base, you can't put them together. Now the second rule states that we're raising it to another exponent. What would we do? Well, we don't add them in this case, we're going to multiply. So the way that it looks is you're going to have one base and 2 exponents. And one of the exponents is going to be outside of parentheses. And when that happens, we're going to simply multiply them together, which is where they got mn. Now let's put this together. If I have x squared, and I'm raising it to the 3rd power. Notice here that I don't have a base right under that 3. It's connected to the original x. So I go 2 times 3, which is 6, so this becomes x to the 6. So you have to know, when do I add the exponents and when do I multiply? So go ahead and try the first one, 8 squared to the 5th. That one, hopefully you noticed it was exactly like what we had just talked about. So we take the 2 and the 5 and we multiply them, and we get h to the 10th. Now the next one, we've got a couple things to deal with. 1, there's more than one thing inside of the parentheses. And 2, the exponent is negative. Well, the negative we'll deal with at the end. What I want you to look at is in this parenthesis here, the negative 3p. Does that negative 3 have an exponent? And hopefully you figured out, yes, it has an exponent of 1. Well, what about the p? Does the p have an exponent? It does. It also has an exponent of 1 since there's not one listed there. So we have to take this negative 2 and we have to multiply it to each exponent. It's kind of like the distributive property, but we only distribute it to the exponents, not to the actual numbers or terms. So we're going to have negative 3, and then 1 times negative 2 is negative 2. And then we're going to have p, and then same thing, 1 times negative 2 is negative 2. And I'm going to put this negative 3 back in parentheses. Negatives, if it starts in a parenthesis, you should keep it in there. Now the first thing is their exponents are negative. Well, I'm not allowed to have negative exponents, so we're not done. Now there's not a fraction in this problem, which means the negative 3 and the p are currently on top. So when I create a fraction, since they're on top and both are connected to a negative 2, they both go to the bottom. So negative 3, and because I'm crossing the line, that negative 2 becomes a positive 2. Same thing with the p to the negative 2, because I'm crossing from top to bottom, it becomes a 2. Now there wasn't anything else in this top part, which means I can get a placeholder, and again that placeholder is 1. And now I check to see if there's anything else I could still simplify. Well, in this case there is negative 3 squared. That simply is negative 3 times negative 3, which is 9. So I have 9p squared, and then I still have that placeholder of 1. And there's my final answer. Go ahead and try the third one. Check with a neighbor as you finish it, and then unpause this to see if you and your neighbor are correct or if only one of you is correct, or so on. So for this one, again, I have more than one thing inside the parentheses. Each of them already have an exponent labeled, so I don't need to fill in a 1. But if there is any missing exponents, like in this one, I would recommend putting that 1 there so you don't forget. So we're going to take this 2 that's on the outside of the parentheses, and we're going to distribute it to each part inside. So m, when I multiply the 2 and the 2, becomes m to the 4th. When I take care of the n, I have 3 times 2, well that's 6, and then I have p, and 4 times 2, which is 8. And there's my answer. Last property we're going to look at today is the division property. If I have, we'll say x to the 5th over x squared. Well, x to the 5th means I've got 5 x's. X squared means I have 2 x's. Now what happens when I have the same thing on top that I do on the bottom? Well, I can cross them out. So this x and this x can cross out. This x and this x can cross out. And I'm left with 3 x's that are on the top. So my answer is x cubed. Now the question is, how do I get from here to here without having to do this in between step every time? Well, to get from a 5 to a 2, to get from a 5 and a 2 to a 3, that means I need to subtract the exponents. So when we multiply, we add them, and when we divide, we subtract them. And that's what it shows below. If you have x to the m over x to the m, you subtract n minus 5m. Now, the one thing you have to be careful about is what we're going to see in the middle example here. So we're going to hold off on that. So go ahead and try the first one, 6 to the 7th over 6 to the 5th. Hopefully you realized that you're going to get 6 squared. If you left it like that, I understand we're working on the exponents, but hopefully you realized, well, I know what 6 squared is. It's 36. So when it is numbers with exponents, we do want to go ahead and keep simplifying. And again, we got that too because it was 6/7 being divided by 6 to the 5th. They have the same base, so we subtract their exponents, and 7 minus 5 is 2. Now let's look at the next one. This one deals with a couple properties here. The first thing is I have exponents, 1 in a parenthesis and 1 outside. Well, that's one of our multiplication rules, so now the question is, do I add these or do I multiply these? Since it's a power to a power, we multiply. So on top it becomes x to the 8th, and on the bottom it becomes x to the 15th. Now, if we subtract these and go top minus bottom, I end up with the negative exponent, because 8 minus 15 is negative 7. But I'm not allowed to have a negative exponent, so I have to figure out another way to approach this, so I save myself some work. And here's how. I ask myself the question, well, where do I have more x's? I have 8 on top, 15 on the bottom, which means I have more on the bottom. How many more on the bottom? Well, there's 7 more. And then because it was more on the bottom, I no longer have anything on top, so I put my placeholder of 1. So if there's more of anything in the bottom, it just means that your answer is going to stay in the bottom. Now, if you were to do x and then 8 minus 15, you get x to the negative 7th. Well, since we're not allowed to have a negative exponent, and that is currently on top, we would have to move it to the bottom of the fraction to make it positive, and that would leave me with a 1 again as a placeholder. Both ways do work, but I do usually find this way to be easier. Simply asking yourself, where are there more of? Last problem for today. And we've got a couple of things going on here. So I have fractions in each of them, and then I have exponents outside that fraction. Well, I'm going to look inside my parentheses, and I want to look for exponents. Do I see any exponents in the parentheses? I don't. That doesn't mean that there aren't any. It just means that they are ones. Every term always has an exponent, whether it's a number or variable, and if one is not listed there, then it means we have those invisible ones. So now we're going to take this negative 1 and we're going to distribute it to every exponent in the problem. Doesn't matter top, bottom, because it's in parentheses, it has to go to them all. So this becomes 3 to the negative 1, c to the negative 1, and negative 2 to the negative 1. Well, negative exponents aren't allowed to stay put, so I know they're all going to change. So the 3 to the negative 1 needs to go to the bottom to make it a positive 3 to the 1. C to the negative 1, same thing, needs to go from the top to the bottom. And that's all it was on top, so now I go to the bottom. There's currently a negative 2 to the negative 1, so that's going to go on top to make that negative 1 positive. So here's the first one. Now some of you might have also looked at that and said, well, if everything's going to turn negative, it means that fraction's going to flip. And yes, you could also think of that. Now we're going to do d over 4. Same thing, even though there's no exponents there, we do have those invisible ones. So we take this one and we move it to both of those. So I have d to the negative 2 over 4 to the negative 2. Not allowed to have those negative exponents here. So since the d is on top being negative, it's going to get moved to the bottom as d squared. The 4 to the negative 2 is on bottom and negative, so it's going to get moved to the top. Well, one more thing that I can do here is 4 squared. I know that that is 16. Now, these were being multiplied by each other at the beginning, so same thing here, we still need to multiply them. So we have negative 2 times 16, because when we multiply fractions, we go straight across. So that's negative 32. On the bottom, I have a 3. There's no number over here to multiply the 3 by, so it's just going to come along. When we have more than one variable in the denominator, we're going to write them in alphabetical order. So I have a c here. There's no other c's to multiply it by, so that comes next, c to the 1 or just c. And then on the bottom, there's still a d squared. There's nothing over here to multiply it by, so it becomes d squared. Last thing to double check, I do have numbers here that I need to think of like as a fraction. Can I simplify negative 32 and a 3? There's no number that they can both divide by, so this is the final answer.